So today we are going to talk about very important topics in object-oriented programming, inheritance interface. We're going to cover a little bit on the third topic, which is called polymorphism, which is not a big deal for this course. Okay, so the plan for today is we're going to review some basic object-oriented programming concepts, including like instance objects, classes, instance variables, and instance methods. And then we're going to dive into the inheritance. So very exciting. And between inheritance and interface, we're going to have a little bit break. And after the interface, we're going to talk about we're going to have lab time. Okay. All right. So let's start with a review. So what is instance and object? So an object is really an entity that has state, behavior, and identity. So for instance, we have an animal class. And we instantiate an animal class, say we have a foggy, animal foggy equals to new animal string foggy. So foggy will be an instance or an object of the animal class. So there are some states for the foggy object. So in our case, for the animal class, what we have is we have a name for the animal and a gut, which is string, list of string. So therefore, the states of the foggy that we instantiated are name and gut. Okay, what about its behavior?
Sorry to interrupt you, but you know, I really like the state, behavior, and identity. And it's not described in quite those terms in the book, but I think just like everybody learned public static void main string args, I think it's useful to remember these three words: state, behavior, and identity. And when we go through our classes, let's try to think of those. I mean, the state is really the middle part of the UML diagram. The behavior is the bottom part. And what would the identity be of an object? How do what distinguishes an object from a class? How do I get an object?
Oh, you have to say like new, you have to instantiate it.
You have to instantiate. And usually, well, no, sorry, for this class, always when you instantiate something, what are you going to do with the result? You're going to say variable name becomes new something. So that variable name is its identity. It's the way you, in programming speak, it's the way you get a handle on that object. It lets you refer to that object. You've given it an identity, and at least for simple ones, they're usually a variable. So I think everybody remember that. State, behavior, and identity. Maybe it'll be on the final.
Sorry, what do you mean by state?
Well, you try.
State is the instance variables. For example, like when we instantiate, instantiate an animal, let's say animal foggy, we give it name, let's say the foggy. So the state, one of its states is this one, name. So it will be foggy. And then we assign, or we should say we instantiate a new list of string and assign to gut. So another state of this foggy will be gut.
And so when Froggy was first instantiated, its state was, we knew its name, Froggy, and it had an empty gut. A little bit later, maybe Froggy would eat a fly. Its state changes. His name is still Froggy, but now its gut is no longer the empty list of strings. It's a one string long list that includes fly. So at any given time, the object has a state which is represented by the current value of its private attributes.
Okay, so how do we instantiate a class or create an object? We use the new operator. So we start with the class name, which is, in this case, we have a string reader. And then we want to create, if we want to create stream reader object, we first need to give the identity, which is SR in this case. And then we use this new stream reader constructor to instantiate. And therefore, we get a stream reader SR that can read a file, which is myfile.txt. Okay, how about class? What is a class? So class is basically a group of objects that shares common state and behavior. In other words, you can think of class as an abstraction of a bunch of objects. For instance, we have, let's say in the real world, we have Honda car, we have Ford car, we have Toyota, all different kind of cars. But if we want to make an abstraction of car, we can just say car, public class car, and say give it has a wheel, it has some speed, it burns gas, blah blah blah. They're all abstract, but each Honda car, each Toyota or Ford car are instances of a car class. So the class defines the data and behavior of instances of this class. For example, we have our class animal. It defines the two states, name and gut, and also defines its behavior. So for instance, I have this method called getName, which returns the name of this animal. And I have this method called greet, which allows the animal object to greet to us. We have this method called eat, that allows us to make the animal to eat a string item. And excrete, which allows us to get one of the item that the animal eats from its gut to us. So a class does not give us a concrete object, but give us the abstraction of it. So how to define a class or to declare a class? We will just use some public class, my class, with this curly bracket, and we will put all of our code in it. So in our example, animal class, we start with declaring this class, which name is animal, and it has its two instance methods called instance variables called name and gut, and we need to give it a constructor. This is a constructor that allow us to instantiate animal. So the constructor in this case will only need a string, which is the name of the animal, and assign this name string verb argument to this name. So when I say this.name, it refers to this name instead of this one. And the name here on the right side of this equal sign will be the argument name. That's how we declare class and create a constructor. Any questions so far? Good. Instance variables. Instance variables are used to keep the state of a class or an object. Instance variables are referred as class attributes, class field, or class variables in some other programming languages. Instance variables are not static. So notice that for my animal class, there's no modifier called static here. There's something like protected, private, but there's no static because they are associated with instances of animal instead of the class animal. Static variables are common to or shared to, I should say, all objects by adding a static modifier. So basically, static variables in a class is not associated with the instance of the class, but the class. So in order to access static variables, you just use the class name and then dot the name of the static variable instead of using an instance to access it. You'll see what I mean by that. So another part of class, important part of class is the instance method. So like instance variables, instance methods are associated with instances of the class instead of the class. So only instances of that class can invoke instance method instead of the class. So for example, I have a class called dog, and then I have two different classes, two different methods. One is public static string get genus, and which return us the genus of a dog, which is canis. And another method called public void bark, and basically that is print out bark, bark, bark in the console. So why is this one static and the other one is not static? Well, for all dogs, regardless of what kind of dog it is, it's Shih Tzu or Husky, whatever it is, they all belong to the same genus, right? Regardless of what kind of dog it is. So that's why it's static. It's associated with class. It's not necessarily associated with any instance of dog. However, if we want a dog to bark, we need to actually have a dog. So therefore, we need an instance to invoke the bark method. Therefore, this bark method should not be static, but an instance method. Does that make sense? Yes?
Just a question. So if you hadn't defined a dog yet, could you still use the get genus method?
Yes. If you want to use this method, you can just say dog dot get genus. It will always return this one, regardless of what dog you have, regardless if you have a dog or not, or dog object or not.
Yeah, yeah.
But if you want to use this method, you must have an instance of dog. So dog, let's say D, or dog, my dog equals to new dog, let's say Tom. And then we can say my dog dot bark.
Yeah.
So the dog can actually bark.
So
Question?
could you use the get genus method with a dog, like a real, like an instance
No.
or an object?
No, you just use the class. Class, this dog,
Right.
dot get genus, and it will return will return us canis because
Yes.
it's not associated with any specific instance of dog. Or what you can do is, instead of using this as a method, you can say public static string genus equals to canis. So in other words, we give that class an attribute, which is genus, and the value of the genus will be canis. They are associated with the class instead of the instance of dog. All right, so this is a little bit extra topic. You don't have to, you're not required to understand what it is. So turns out there are two different fundamental types in C#. So before we talk about types like int, double, bool, char, these are called primitive types or value types. Means that when you declare them and assign a value to them, the name and the value are bounded. And there's no other way that you can make the other variable to refer to this one. However, for reference type, it's a little bit different. You declare a reference and give some value to it, and then you can give another reference that points to the same value. So basically, two references can refer to the same thing. So, what are reference types? So, for instance, string, animal, class would create, stream reader, stream writer, list, dictionary, and many other classes that are in C#. So two references can refer to the same value or same thing, but two value types cannot refer to the same thing. So why do we need a reference type? Well, reference type came from history, which is called pointer. So there's such a thing called pointer in history. It's mostly heavily used in C and C++, those low-level languages, which requires a lot of memory management, and pointer could be very handy in that case. However, pointer is also a curse in disguise. It causes a lot of bugs in the programs. So later, as the programming language develops, programmers become less and less want to deal with those memory issues. So some programming language designers, they implement this reference type and some memory management system so that programmers can write programs without you worrying about memories. And they just need to use reference to refer to different things in the program. So that's why we need reference type. But of course, you're not required to understand this. But so how does the reference type and variable type look like in the memory? So for this 3 lines of code, I declare int, give a variable name age, and assign 5 to it. What it does is, in the memory, which are these boxes, it specifies the type and its identifier, and bound this 5 to them. So 5 is bounded to 8. Now in the second line of code, I declare a string name and assign Tom to it. What it does is that it allocates a memory space, give a type string and identifier name, but put this string Tom in somewhere else instead of here, and then use this curved like as a reference to it. So the name ref is a reference of this value Tom. And then the third line of code, I have string Tom name equals name. What it does is it allocates me another memory space, have a string type and Tom name identifier, and then what the code does is it first looks up where name refers to, what name is. So it first goes to name, and then find out name is reference of Tom, so it will go back to refers to Tom. So therefore, we can have 2 variables refer to the same thing, but for this one, you cannot do it. If you say something like int my age equals to age, you will get a copy of this. So int my age equals to 5 as well, instead of pointing to this one. All right. So that was basically a brief review of class and object and instance variables. So now we're going to jump into our new topic, which is inheritance. Okay, as my lecture always goes like this, so we always have to start with a problem. So this time we have a problem like this. So if we have a class, we already implemented class animal. Now we want to implement a little bit more specialized classes such as dog, cat, cow, horse, etc. And they all have some similar attributes, right? They are all animals. Like they all have name, guts, they can greet, they can excrete, they can eat. The problem is, if we ever want to implement these classes, do we have to write them like individually? Like, do we have to redo everything that we have already done in animal? I mean, animal is not a large class. It doesn't really hurt that much if we just copy and paste code from animal to all these classes and just do a little bit modification. But for some large programming projects, this can be very, very bad, very tedious. So what can we do with it? The answer is, or the solution is, inheritance. So class with inheritance, what we can do is we can derive a class that's based on some class that we already implemented and add some modification to it. So the derived class therefore inherits field and method from the base class. So for instance, what we can do is instead of rewrite everything like dog, cat, cow, horse, we can just somehow make them inherit animals. So therefore, we inherit name, gut, greet, eat, and excrete without rewriting everything. So in inheritance, we need 2 classes. So the first class is called base class. Base class is where you start from, so where you inherit from. In our case, the base class will be animal class. Base class is also called superclass or parent class in some programming languages. And then we have a derived class. derived class is a class that we get from after the inheritance. So derived class is also called subclasses, subclass, extended class, child class, in other terminologies. There's one exception. Every class, all the classes in C# are inherited or derived from the class called object. Object has no superclass or base class because everything starts from object. It's the origin of all classes in C#. So this is an only exception in C#. Some characteristics in inheritance in C#. So the first thing is single inheritance. What does it mean? It means that one class can only inherit from one class at a time. It cannot inherit from multiple classes simultaneously. That's called, if you want one class to inherit from multiple classes simultaneously, it's called multi-inheritance, which is a big problem, and we'll talk about later in the interface lecture. And the second thing is transitiveness. What does it mean? So if I have three classes, class A is the base class, class B is derived from A, so class B have everything from A. But then class C is derived from B, so class C has B, everything from B. However, since B already have everything from A, therefore class C also have things from A as well. So that's called transitiveness of inheritance. What does it look like when we inherit class? So how should we inherit? So we always start from a base class that is very abstract, very raw, does not give much things to do. It's basically a skeleton. And then when we do inheritance, we add a little bit of specialization to the new class. For instance, we start with an animal class, which is pretty abstract. Animal can be anything. It can be dog, can be horse, can be fish, can be whatever. And then from animal class, we can derive those a little bit specialized class, such as dog, cat, horse, and cow. However, even though they are a little bit specialized, they're still pretty general, right? So for dog, we can have some more specialized class like husky dog, or Shih Tzu dog. Cat, we can have tabby cat, or white cat, black cat, gray cat. Or we have, for horse, we can have walker horse or runner horse. And for cow, we can have Holstein cow or maybe other cows. So as the inheritance goes, the derived classes are getting more and more specialized. And if you go up to the tree, you will see the class are getting more and more generalized. So the relationship between classes in inheritance is called is-a relationship. Derived class is a specialized case of the base class. Now, example before we have dog derived from animal, so therefore, dog class is a case, or actually is an animal. And husky is derived from dog. Therefore, we can say husky is a dog. Can we say the other way or not? No, we can't. We cannot say dog is a husky because there are many kinds of dogs. Husky is just one specialized class of dog. So, in other words, in another word, you can think of this: husky is a subset of dog. So you can say husky is a dog. The dog is not a husky because dog has more other classes. So another thing is, because all classes in C# are derived from the class called object, therefore it's safe to say that all classes is an object. There's another relationship called hazard relationship. This is a little bit, this is not very strongly related to inheritance because this reflects more about composition between classes instead of inheritance. So we're not going to talk about this here. Any questions? Yes.
So like, if animal has like a string and list, does that mean like all the subsets will have a string and list too?
All these derived classes of
Right.
animal
Okay.
will have a string. Yes.
Okay.
String list. Yes. Okay. No. Now a little bit more details about. Do you have questions?
Oh, sorry, no,
Okay,
my
okay.
arguments.
So a little bit more details about inheritance. So inheritance is starting in C#. When you derive the class B, if you derive class B from class A, class B implicitly gains all the members of the base class, such as the instance method and instance variables. Derived class can have its own specializations, so therefore derived class can have add its own instance variables, can add its own instance method. For one thing, because all classes in C# are derived from the object class, therefore all the methods are declared, or all the members are declared in the object class. Every class in C# will get it. The most commonly used four methods for object class are toString, equals, getType, and getHashCode. We are probably mostly using these two methods, but these two you will learn later in the class, later in your CS career if you goes to that direction. Inheritance scopes. Actually, we're going to skip this slide for right now. We're going to come back later. So I want to show you how you can actually use inheritance in your code. So in this case, what we're going to do is we're going to derive a class, dog, based on a class that we have already implemented, which is animal. So what we want to do in the dog class is we want dog to be a little bit different from animal. Therefore, dog should be able to bark. Not all animals can bark, but dog can bark. Dog should greet in dog's fashion. It's something made up. So therefore, dog should have a little bit different greet method from animals. So what does it look like in the code? We start with our animal class, as we have already probably known very well so far. We declare the class, give its instance variables, and declare the constructor, declare some method, public getName, greet, eat, and xGreet. And then how do we start from here to inherit everything from animal class? We declare the class called public class dog. And then we use this very important column operator. And between this column operator and this left curly bracket, we put the class that we want to inherit from here. So in this case, we want our dog to inherit from animal. So therefore, put an animal class here. You can ignore this part right now. Just by this line of code, dog has already inherited everything from animal, including getName, greet, eat, xGreet, and these two instance variables. However, the only thing that is not inherited from animal is a constructor. We have to, for the new dog class, we have actually implement our constructor for dog. Because I want to add a little bit more features to dog, or I should say, derived class can have its own instance variables. So therefore, I gave a new instance variable for dog, which is the owner information, and I initialize it as unknown. It's pretty natural things to do. So for the constructor, like I said, we had to implement that. We cannot inherit that from the animal class. Therefore, we need to declare it here, public dog, and use string name. Here I use this column operator again. And then between this column operator and this left bracket, I have this thing called base parenthesis name. What this does is that it tells the program that instead of implementing this dog constructor, we use the base class constructor, which is this. This allows us to initialize this dog state this way. So therefore, by calling this base parenthesis name, it will do is it will initialize the name to this string variable and initialize the gut as an empty list.
So that's in place of a constructor?
What?
Like that, the public dog string name, like is that basically in place of a constructor?
No, this is still the constructor, but in this case, I don't want to implement that. All I did was I just use the base class constructor that do everything for us. This is pretty common to use.
Right, it's pretty common. Now, it occurs to me, Yuri, maybe we can answer this question by adding another constructor. So what if we wanted to construct a dog that had both a name and an owner? That, I think, would show the difference.
Okay, so what we can do, so your owner, right? What we can do is we can have
as many constructors as you want, as long as they
string
have
name
names.
and string owner. What we can do here is we can say this name, we can say base, or whoops, not here. What I would do is I use the base name to initialize the name of the dog and the gut. And then because I have this owner information here, I will need to say this owner refers to the private instance variable, and then assign the argument owner to this owner.
And so if I could just offer in English what this does, the second constructor on line 18 and 19, what it says is when I'm ready to instantiate a dog and I want to specify the dog's name and the dog's owner, I'm going to use the base constructor, in other words, the animal constructor, and do anything the animal constructor does when given a name. When that's all done, I'm also going to set the dog's owner up.
So if you were like running this code, would you like delete the public dogs? Yeah, does that have a purpose anymore now that you have the constructor below?
No.
Okay.
Both constructor will work. Both constructor will instantiate a dog for you. The first constructor will instantiate a dog with a name, but the owner will be unknown.
Yeah, it's just more like general.
Yes, but the second constructor, if you say name is Tom, owner is Bob, so it will instantiate a dog that has a name Tom, and an owner's name is Bob.
And
Very
so
good
again,
question.
as a class designer, you decide what factory methods, what public methods you want to provide. And so with the change Ewing's just made now, you've decided that there will be two ways to instantiate a new dog. One giving just a name, and the other one giving the name and an owner. And so the users now can do either one. And indeed, the code is set up right here so that no matter what they do, the state of the dog will be complete. It will either have a name and say unknown, or it will have a name and an owner.
Okay, question?
So does the base refer to the animal constructor?
Yes.
So I'm trying to.
Yes.
So then the name is like the parameter in the animal
Yes.
constructor?
So if you take a look at the animal constructor, it only takes one argument, which is string name. And here, I also use the same type of argument, which is string name, And because this name has a type of string, so therefore I can use the base constructor or the animal constructor to instantiate it.
How would you add like another base, or I guess not constructor is the name, but like say you want to add like I think like gut was our other field from animal. How would you add that?
Isn't that already in there?
Yes, gut is implicitly inherited.
Gotcha.
Yeah, so that was my thing. It's
Yeah, do you see what I'm saying? Like,
it only says name, but
Uh-huh.
it's like referring to everything in the animal constructor.
But gut isn't like name because gut is
yeah.
like
I guess yeah, that's a bad example. But like, what if? Yeah, I guess everything is in that one constructor. If you had multiple constructors
Okay.
in animal, how would you add those? That's yeah.
Um,
That's more what I'm asking.
So if you have, okay, let's say if I have another constructor here, say public animal, and give no name here, and I'll say this name equals to unknown, and then initialize this gut as a new list string. So for the dog class, when it called based on name, it will look for a constructor that matches it. And it will find out this constructor matches because if this one takes an
Okay.
argument, this one does not have any argument.
Uh-huh.
So therefore, yes, it won't be like, you don't need to worry about like they kind of like misunderstood each other. No, it won't happen.
If you have,
Very good question.
And when you see base, you can really think of it as meaning whatever was to the right of the colon where you define the class. So in this case, it would be nicer if you could just say animal name, but you can't. You have to refer to it as a base.
Yes.
But like, say you wanted to use like multiple constructors from animal at once. Like, can you do that? Like in one signature?
Why would you do that? I mean, like one constructor already instantiate for you. Like,
It's hypothetical.
no, there's no reason to use that. I would say, no reason to use multiple constructor at a time. Yeah.
Well, in fact, at least for right now, my rule is you use one constructor, and you use one new for any variable. So you can pick from among all the possible constructors, but only use one and only use new once.
How would you refer to, like, if you had, like, if your class was Husky,
Okay.
and then that class Husky refers to the class Dog, and the class Dog refers to the class Animal.
No, I mean Husky inherit from
Or
dog.
inherits, yeah.
Okay, so what do you mean? Like, what's your question?
When you say base, like, I can see it's referring to Animal,
Yes.
but how would that work?
Okay, so this base will call the constructor of the base, the class it derived from. So for example, if I have a dog, animal, dog, and husky, and then in the husky I say base name, I will refer to the dog's base instead of like the dog's constructor instead of the animal's constructor because.
And then in the dog's constructor, you refer to the animal's constructor.
Yes,
So
because-
that's how it kinda.
Because it's derived from animal class.
Inheritance is always one generation at a time.
Like,
So you
only
could have
one
a
back.
husky class which has everything that a dog has, that has everything that an animal has, and then down in the husky class,
Like what animal?
you could add unique things to a husky. Let's see, a husky differently from a dog would have a length of his hair or something. So you would add that
Like a
just in there.
size.
Or, yeah,
Size
maybe the size, although a dog could have a size too.
Yeah.
But I think something unique to a husky that I want to implement just for a husky. A husky would have a sled pulling capacity. You can pull 20 kilos or whatever.
Okay. Question?
Could you ever use multiple base classes at the same time? Like, could you have like dog, animal, pet, or something?
No, you can't. That's called multi-inheritance. We're going to talk about it in interface lecture. And that's multi-inheritance is very interesting, but it's also very bad. It's a curse. So we'll talk about why. in about 1 hour.
So at least in C#, with inheritance, again, we'll come to this in interfaces, but in inheritance, everybody has one parent. And just like in humans, that parent has one parent, or two. So you can go up the generation. You can only go one step, right? You can't go multiple places.
Okay.
It's just more like cloning than humans, I guess.
Alright, we'll continue to talk about our dog class. So, dog class can have its own instance method. So in this case, I added the bark method, which basically just print out bark, bark, bark in the console. And then I said in the slide that I want the dog to greet in a different fashion. So what I would do is I would override the greet method that I inherited from animal, which is public virtual void greet. And instead of print out like in the animal fashion, greet in the animal fashion, say hi, my name is blah blah blah, I will say bark, I am something bark, and bark, my master is something bark. That sounds more like a dog instead of just a general animal. And another instance method that I added to dog is set owner, which allow us to set an owner's information based on the owner name that we pass to it. Now let's see, okay, and now in the executable programs, so animal and dogs, they're classes, they're not executable, they're there to give us a blueprint or an abstraction of the data animal and data dog. In our executable program, what I have here is I use the console read line, console write line to get the dog name and animal's name from user input, and I also get the owner information from from console input, and then I declare an animal object, I instantiate an animal object and the dog object, and then set the owner information of the dog. And then I make both animal and dog greet. I also make both animal and dog eat something. So in this case, animal eat grass and more grass, and this dog somehow likes to eat seafood, so it's crab and fish. And then I'll make the dog bark, and then I'll also make them to excrete. So let's see how the program works. Oops.
Yeah. Okay, good. Okay, now we can run the program. So first, I enter the name of the animal. Let's say it's Froggy. And then I enter the name of the dog. Let's say it's Hans. And the owner of dog Hans would be, let's say, Tom. Now the output here is here. So we start with animal greet. You can see, hey, my name is Froggy. And then dog greet, you can see the dog greet in its own fashion. It greets as bark, I am Hans, bark. And bark, my master is Tom, bark. So they both have the greet method, but because I overrided the dog's greet method, therefore dog greets differently from animal. And then I make both animal and dog eat something. Oops. And then make them excrete and get to their faces. So what I have here is when the animal excrete, the faces of Froggy is grass, and then I get the faces of dog, and in which is crab, because dog eat crab, animal eat grass. So when animal excrete, it excrete grass first, and then when dog excrete, it excrete crab first. So some questions here. Can animal invoke the bark method? Absolutely not, because bark method is implemented in the dog class, and dog is derived from animal. So therefore, only instances of dog can invoke bark method instead of instances of animal. However, you can see here, even if I didn't define the eat method in the dog class, my dog object can still eat a crab and excrete it. So this is the power of inheritance, is that I can inherit the two methods, at least here is eat and excrete, without writing them in my dog class. So that solves our problem. So if we want to instantiate or implement cat class or fish or some other classes, we can use inheritance to make them all inherit from animal instead of writing everything from scratch. Any questions here so far?
Well, I have one. That we'll put your main program for your test dog.
Okay.
So at the end here, go down to the end, after what we've just done and demonstrated, who can tell me the state of the dog? What would the internal state be at this moment of the dog object called D?
Okay, so its name is Hans, and in its gut or it has fish.
Yes.
Yeah.
What about its
What
owner?
else?
What about what?
Owner?
Oh, its owner was Tom.
Yes.
All right, so that's the complete state of the dog, which some parts were defined in the class animal, and some parts were defined in the class dog. But now a dog has all of them because a dog is a specialization of animal. So anything a dog has, anything an animal has, a dog also has, plus whatever you added in the dog class.
All right. So let's go back to our slides before. We skipped one of them, which is scopes. So you probably have noticed that I have different modifiers to those methods and variables. Some of them are public, some of them are private, and some of them are protected. What does that mean? So for public variables and methods, they are accessible not only in the class itself, but also in other classes and the classes that derived from it. For protected variables and methods, only classes that derived from it and within the class itself, you can access that. And for private variables and methods, you can access them only within the class. This is a little bit complicated, but for right now, what we want you guys to remember is that instance variables should always be private, and instance method, you should make them private first, and then later on, if you want to make it public, you can make them public. Why is that? For instance, if I implement my own string class, I have all kind of maneuvers in it. I don't want to show how nasty my code is. So therefore, I will make everything private and only expose a little bit things such as the length of the string, or string concatenation, or append a string. And however, if I make everything public, then people will see, oh, your code do this, your string class do that, and then in their code we just use string public, invoke some method that's public, and later on if I decide to make them all private, then their code will not work because all my class methods are private and they will rely on those methods and they assume that it's always public. So therefore you should make everything private, and then later on if you decide, okay, it's okay to make it public, then make it public. That's what many programming languages do, especially Java. Like everything starts with private, and then if the developer of Java they decide, okay, we should make this
public because it's very useful to Java developers. So they will make some methods in the class public. All right. So there's a few notes on the program. So to inherit class, you must use this column operator and put the class that you want to inherit from here. You can only put one class at a time here. You cannot put two classes. For example, if you have an animal class and you have something like a spacecraft somehow, you cannot inherit from animal and spacecraft at the same time. You can only inherit from one class at a time. And if you want to override some method in your derived class, you need to make sure that those methods were labeled as virtual in their base class. For instance, in my dog class, I override the greet method, and this is because in my animal class, I have this modifier called virtual, which makes this greet method virtual. Well, what does it mean? It means that the derived class can override this method. If I do not label, or if I do not have a virtual modifier here, like this get name and eat, that means I cannot override them in my dog class. So if I try to say something like public override void eat, which does not have the modifier virtual, then the program will not even be compiled. So make sure that you override methods that are only labeled as virtual.
Or you're going to compile it. Now, can anybody think of a virtual method that somebody else defined that we've been working with for the last couple of weeks?
The two-string.
Yes.
Two-string. So two-string is defined as a virtual method
Is that like in the object?
in the object class. And as Yubing said, everything in C#, well, all classes inherit object automatically, even though it doesn't appear on the definition. And so you now, when you program your class, can, if you wish, override toString and change how your object appears in printout.
Another thing is, derived class cannot access private members of the base class, but they can access protected and public members. For my program I have here, is that I intentionally made this name, instance variable name of the animal class as protected. Therefore, I can refer to this variable in my derived class, which is dog, here. I can say this name, even though it's not declared here, but because this is protected, so therefore I can refer to it. If I make it private, this program will not be compiled. So for this, another instance is this list got is private. Therefore, there's no way I can refer to this variable in the dog class. If I try to do that, the program will not even be compiled. But right now, let's just make everything, all the instance variables private and method public. That's for right now. Okay, so how is inheritance supported in different programming languages? So some programming languages like C does not support inheritance at all. Why is that? C was invented in like 1970-ish. That was before the object-oriented technology was becoming mature. And on top of that, C was mostly used for system programming language and programming machines. So they're very closely interact with the bare metal. So if we add any object-oriented feature to C, it will make this language very slow. So therefore, to keep the speed high, they do not have any object-oriented feature in it. Some languages like C#, Java, and Ruby. Okay. just outside. It's the outside truck, I think. So for some languages like Java, C#, and Ruby, they only support single inheritance. What does it mean is that one class can only derive from another class at a time. They cannot derive from multiple classes simultaneously. But there are exceptions. C++, Python, and Common Lisp, they support multiple inheritance. So they allow you to derive a class from multiple classes at a time. And that's, in most part of the history, it's a bad practice. There are a lot of problems caused by multiple inheritance, and we're going to talk about that in our interface lecture. Generally speaking, inheritance is more commonly seen in those object-oriented languages such as Java and C# and C++. System programming language like C does not support object-oriented programming paradigm. Do you want to use inheritance all the time? Not always. One of the reasons is that inheritance increases the complexity of your code, of your program structure. So we're going to talk about that in our interface lecture. But right now, I want to say sometimes you want to use inheritance because it reduces you don't have to reinvent the wheel all the time. But most of the time, inheritance increases the complexity. So a good example of using inheritance is like Java and C#. So for example, in Java, in 1995, when they first released, it only contains hundreds of classes. But today, Java contains like thousands of classes. It's built on based on the previous classes. And that is a very successful example of inheritance because if their base code are very robust, then they can build more features on top of it and without rewriting everything. But and then for game programming, for game development. So if you guys play like games like Diablo 1, Diablo 2, or StarCraft, or those like World of Warcraft, you probably can tell that different generations of World of Warcraft look pretty the same thing. And Diablo 2 and Diablo 1 looks pretty same. It's because the Blizzard, the company that developed those games, they use inheritance so that their new games use the code that they used before and add a little bit more features and then make it a new game. And will that always work? No. For instance, Diablo 3 is quite different from Diablo 2. The user interface, the mechanics, the whole animations are very different. And because Blizzard decided, okay, it's time to change technology. So they reinvented the game engine, they rewrite everything. That's why there was about like 10 years gap between the release of Diablo 2 and Diablo 3 because they have to redo everything instead of inherit from the old code. So inheritance is very successful in the industry, but it comes with a cost, which is the complexity of code. All right, so this is for the lecture for right now. We're going to take about 10 to 15 minutes break, and we'll come back and talk about another exciting topic, which is interface.
What is a decoupler?
Interface lecture. Okay. So interface. Here's another problem. How do we implement a Griffin? Suppose we have a class of eagle and lion, and they all derived from class called animal. And now we want to implement the class of Griffin. How do we do it? If multiple inheritance is an option, would you use it? Can we make this work? So especially that if both eagle and lion are derived from animal, they all have a greet, act, greet, eat method. And then we want our griffin to inherit from both eagle and lion. Does that work? Like, if we inherit from both of them, whose method should we inherit from? So this is a complex, this is a problem of multiple inheritance is that we cannot deal with it. So this is called the deadly diamond of death. what it does is we start from a base class called animal. It has virtual void greet, virtual void eat, and virtual string actree. And then we have two derived class, learn and eagle. And then we have override void greet, override eat, override excrete, and then we override here as well. And now, because it's natural that Griffin is a combination of learn and eagle, so we make Griffin inherit from learn and eagle. And then here's come the problem. Whose greet method should we inherit from if they are implemented differently? Should the Griffin inherit from learn's greet, eagle's eat, learn's greet, x greet? Does that make sense? No. So that's the problem of multiple inheritance, is that when we try to inherit from two classes that are originate from this one class, there's ambiguity here. Another problem is the complexity. Multiple inheritance is complex. It's very complicated. I cannot describe that for you, but awesome instructor from Berkeley can do that for me. Here's a video clip.
Yeah, yeah. Oh.
Okay, let's talk about designing with multiple inheritance. Usually you don't, because it's complicated.
Whoops.
It's hard for me to construct an example in code of just how complicated multiple inheritance is. I'm going to show you an analogy instead. The complications of biological or human inheritance.
Hang on a second. I think
How do you think about how you came to be? Well, you think you had a grandma and a grand...
I'm sorry. Give me a second. The screen doesn't work. Oh. Oops. Okay. Now I have to restart everything.
Okay, let's talk about designing with multiple inheritance. Usually you don't, because it's complicated. It's hard for me to construct an example in code of just how complicated multiple inheritance is. So I'm going to show you an analogy instead. The complications of biological or human inheritance. So how do you think about how you came to be? Well, you think you had a grandma and a grandpa and a granddaddy and a grandmammy, and they had your mom and dad, and then there's you. That's how the world works, right? And if your grandma and your grandpa have another kid, well, that will make your aunt. And other strange things can happen. Like, let's say, history went as it went, and so your grandma actually had a kid with some other guy. That will be your half aunt. So half aunt is a technical term. It describes someone who you share one grandparent with. And if your half aunt gets together with some other guy and has a kid, that's your half cousin, natural thing to have. But this picture of the tree just growing and growing, the farther back in time you go, must be inaccurate. Because it's growing exponentially. And yet there were fewer people on Earth 200 years ago than there are now. There must be some sharing in the tree. I mean, how would that work? Well, let's say that this some guy was not just some guy, but in fact was granddaddy. That's your double half aunt. There are real terms for this stuff. I mean, you got to know what your relationship is with this person. This is your double half aunt. So you have a half an aunt with grandma, you got a half an aunt with granddaddy.
So does it just make it right?
If you can have a double half aunt, of course you can have a double half cousin. So a double half cousin is someone who you share two grandparents with. If you could have a double half aunt, you could have double half uncle. So a double half uncle is a child of grandmammy and grandpa. And you can probably see where this is going. What happens if this some other guy is in fact your double half uncle? Well, nothing that weird has happened. But that is your quadruple half cousin. Someone who you share all four grandparents with. So what's the moral of the story here is that multiple inheritance gets complicated very quickly, so you might be careful when you use it. Don't use it too much. And that's all for today. See ya.
The line is you can't pick your ancestors.
Okay, so basically, in the Berkeley they use Python, which supports multiple inheritance. So they talk about that, but here we don't have the problem. So as you can tell in the video clip I showed you, like multiple inheritance goes very complicated. So we don't want to do that, and that's why like Java and the C#, which came after C++, which supports multiple inheritance, they declined that idea. They say, oh, we don't want to do multiple inheritance. We just do single inheritance. So, how do we do that? How do we solve this problem? We want to make a griffin that has some characteristics of lion and eagle. Well, turns out there's a solution. It's called interface. It's originally come up by Sun Microsystem, I think, who invented Java programming language. Interface. What the interface does is that it describes the behavior of a type, but does not give any implementation. So in the real-world example, it's like USB interface, USB port, power outlet, your car driving system, and all different kinds of PC. So for instance, with this USB port, interfaces like this, I can plug in my phone charger, I can plug in my mouse, I can plug in the keyboard, I can plug anything that can be connected with USB. It doesn't matter, as long as it has a USB interface. It will work. Similar thing here for power outlet. As long as the outlet matches, I can plug in my air conditioner, I can plug in my PC, I can plug in my phone charger, whatever matches that, it will work. Same for the car. It's like, especially for car and computer, it's like they all look similar. Different car made a little bit different. They have different buttons, blah blah blah, but they all have the same wheel and brake system and things like that, and the gear. So it presents you an interface which looks like this, but their implementation might be different. Toyota may have an engine A in the car, and Ford may have an engine B in the car. Their engines are different, but the interface is the same, so you can drive them without worrying about anything inside of it. And same thing for Mac and PC. Mac and PC looks very different, but they all have the same similar keyboard layout. They all have like mouse touchpad. They all have like monitors, so you can use them without need to adjust much. So that's the idea of interface, is that we can use an interface to inherit a lot of characteristics at a time. So interface in the program only contains the signature of a function or method and no implementations at all. And class that wants to implement an interface must implement all the methods that are specified in the interface. And the biggest thing is a class can implement multiple interfaces at one time. So by implementing multiple interfaces at a time, you kind of mimic the inheritance. So how does it look? Okay, let's start with interface. How do we declare interface? In order to make the Griffin class work, we need to analyze our lion and eagle a little bit. So basically, lion is a mammal, so it's kind of it's natural for us to make an interface of mammal that can breathe. Well, lion doesn't really have much characteristics compared with other kind of animals, and eagle is a little bit different. It can fly. So therefore, we have a defined interface, let's say iFlyable, and which has a method called fly. And there's a convention in C# is that all the interfaces that you declare must start with a capital letter I, which indicates that it's an interface, it's not a class. And then followed by the capital letter I, you actually give the name of the interface, which also starts with a capital letter. So therefore, there are two capital letters in interface declaration. Okay. So now with that interface, we can start implement our Griffin
class. So our interface starts from here, iFlyable, which has only a function signature void fly. It doesn't give any implementation. And then another interface for mammals. So it has a method called breed, which is something I made up, doesn't really matter. Notice that for these two interfaces, many other classes can implement them. For instance, Eagle can implement this interface. Owl can implement it. Plane can implement. Spacecraft and Griffin. So therefore, they all share the same thing. It looks like they all inherit from iFlyable. And similarly, human, Griffin, Tauren, or whatever. I mean, Tauren is a kind of race in the World of Warcraft if you ever played that game. They all can implement this interface called iMemo. So as you can see, Griffin, it looks like Griffin inherit from this class called iMemo, and Griffin also seems like it inherits from a class called iFlyable. Therefore, it looks like the Griffin inherits from two classes, but actually not. It just implements two interfaces. So now let's take a look at our Eagle class, which we derive from our animal class, and we also implement the iFlyable interface. So the constructor looks the same. And we can overwrite the greet method, and then we must implement this method or this function called fly, which is in this iFlyable interface. So if you do not implement this method, or like if you just like say I totally comment this out, then this program will not compile because I tell that program that I want to implement this interface, but I didn't give any implementation. So therefore, you must implement this method. In this case, when eagle fly, the eagle just say, I am blah blah the eagle, and I can fly. And then for lion, what we can do is, what I did is I declare the constructor, override the greet method, and then implement the method in the memo interface, which is breed, and it gives us, of course, breed. I mean, for lion, it just when it's breed, it just gave you a new lion, right? So I just say junior something, the name, the lion. So basically indicates it's child. How do I do in the Griffin one? So my Griffin can inherit from animal. Meanwhile, also implement the iFlyable and iMemo interface. Constructor looks the same. And I can I also override the greet method, and then I have its own implementation of fly and breed. And then in the executable program, I start with declaring animal as a Griffin, because Griffin is as a derived class of animal is an animal. So therefore, I can say new Griffin Alice G1, but declare as a type of animal. And then I give another Griffin Bob, which actually is declared as a Griffin. And then I also can declare Griffin Cassandra as an iFlyable type. And the fourth one will be a Griffin David, which is an iMemo type. So therefore, you can say they are all assigned as a Griffin, but they have different type. This is what we call look like multiple inheritance. Is that looks like a Griffin inherit from three classes: animal, iFlyable, iMemo. But actually, Griffin only inherit from animal and just implement these two interfaces.
So why
Question?
would you not just say animal for all of them? Like, what does saying Griffin or iFlyable or iMemo first change about
Good
that.
question.
Like
So,
Yes.
before Yubing answers, say the question again. I'm trying to get some other people to answer. What's the difference? You're talking about the name on the left, right?
Yeah, the first name.
What's the difference between saying animal G1 versus saying Griffin G1? Somebody else think? Okay, go ahead, Ariana.
So the iFlyable G3 will only have the method like to fly, whereas the animal will have all methods in animal, and the Griffin will have all methods like in animal and those of the Griffin. Like the G2.
Maybe we'll run it and see.
I would say that's a very good answer. So Griffin, as we have shown before, derived from animal. Therefore, we can say new Griffin and assign to animal because Griffin is an animal. And this one, we just declare Griffin as a Griffin, nothing special. Third one, because Griffin implements this interface called iFlyable, therefore we can say Griffin is a iFlyable. Similar here, because Griffin also implemented the interface iMemo, therefore we can say Griffin is a iMemo. Similar here, we declare Eagle as an Eagle, and then because Eagle also implemented this interface called iFlyable, therefore we can say Eagle is a iFlyable. Okay, now, because G1 and G2 are declared as animal and Griffin is derived from animal, therefore I can make G1 and G2 greet to us. And then G3, since it's declared as an iFlyable method, iFlyable type, and the only method that an iFlyable type can invoke is this method, fly. Therefore, even if it's assigned as a type of Griffin, the only method it can invoke for G3 is fly.
In other words, the type is most critical. And again, that's why I've encouraged you, unlike you being, to separate these on different lines, because you really need to think at the point where you declare the type what you want to do with that variable. And then later, if you instantiate it, you can assign whatever that type allows, but it's the type declaration that controls its behavior.
Okay, so for E1 and E2, since the E1 is Eagle, it implements the iFlyable method, iFlyable interface, so therefore it can invoke the fly method. And E2, since it's declared as iFlyable type, therefore the only method it can invoke is fly. And then we make G4, which is iMemo, which has a method breed. We make the G4 breed and get the child name, and we print out what the child name is. And
In fact, can you, does your IDE give you pop-up possibilities? Just type a new line of, what is it, G3 dot, see what it gives you as pop-up.
it does not because it's a text editor.
Yeah, okay. You can't. Because if you were in Xamarin, you would see, based on the type, what methods that object can use.
Yeah, for me it's a little bit challenging because I actually need to know which method, which classes and which interface has which method instead of using a IDE like Xamarin Studio. Okay, and now here's another interesting topic. It's called polymorphism. Here, I declare 3 objects: animal lion, and give its name as Simba. Animal lion declares a type of animal, but assign an object as lion. And eagle, I declare it as an animal type, but assign an object or instance of eagle. And then the third thing is griffin.
I declare it as a type of animal, but assign an object of griffin. Now, I can make a generic list of animals that put lion, eagle, and griffin in them. Even though lion has data, or actually is an instance of lion class, eagle is an instance of eagle, and griffin is an instance of griffin. But because they are declared type as animal, therefore, animal has different form, or can be represented differently in a class or in a program, and this is called polymorphism. One class can be represented differently.
And again, remember back to the first part, a griffin is an animal, an eagle is an animal, and a lion is an animal. Back in the code where we declared them.
And similarly, I create another list of iflyable type, and I can add those data that I declared as iflyable to this list. So in this case, G3, which is Griffin Cassandra, was declared as iflyable, and E2, which is iflyable E2, declared as iflyable, but is actually an eagle object, Frank, to this list. Now this is the power of another thing of interfaces. Like it allows me to manage all these different objects as if they're the same. So even though this is lion, eagle, griffin, and different, this is like eagle or like griffin 3 and eagle 2, but I can manage them as animal and iflyable without knowing what exact class they belong to. So for this list of animals, I can make them all greet to us, and for this list of flyable object, I can make them all fly. So how does the code look when it runs? Okay, so first thing we have is that has output is G1 greet, and G1 is a Griffin Alice. But how does it greet to us? I say, aha, I'm Alice the Griffin, I can fly. So G1 invoke the greet method, which actually instead of invoking this method, which is hi, my name is Alice, it invokes this method, which is defined in the Griffin, which print out, haha, I am Alice the Griffin, I can fly.
Because greet was overridden here in the definition of Griffin.
Can you say that one more time, please?
So when Alice greet, when Alice greet here, G1, instead of, although it's declared as animal type, so naturally we'll think, okay, probably invoke the method of the animal, which is supposed to be, hi, my name is Alice. Instead, it invokes the greet method of the Griffin class, which is, haha, I am Alice the Griffin, I can fly. That's what you see here. So even if we present this new Griffin object as an animal to the program, when the program runs, it will check this G1 type and find out it's actually Griffin. Therefore, instead of invoking this greet method in the animal class, it actually invokes the...
Let me just show you, this is a subtle point. So you said it was an animal. We're now going to invoke the greet method. And so go back to animal for a minute. So let's look at what the animal's greet behavior does. It says virtual. Aha. So at runtime, this was Alice, what was this griffin's name?
Alice.
Alice. Because it says virtual here, we're going to say, oh, well, before I do animals greet, let's see, because maybe it's been overwritten by whatever Alice really is. So you go back and look, oh, Alice is a
Griffin.
Therefore, we'll use Alice's greet method instead of the default animal greet method. Okay, so go ahead to the next part.
Next part, Bob greet to us. And what is Bob? Bob is here. Bob is declared as a griffin and is assigned as a griffin object. So therefore, Bob just directly invoke this method. Say, haha, I am Bob the griffin, I can fly.
So in the case of Bob, those two lines, those greets, end up doing the same thing, but in the case of Bob, it's done quicker. Or more directly, I think, depending on exactly what the compiler does. It probably really runs the same speed either one. But in the case of Alice, because we said G1 is an animal, it goes through that separate step of looking to see whether any of Alice's behaviors need to be applied for the Griffin class instead.
So can I make G3 and G4 greet? We can give it a try.
Noted.
The compiler gives me an error saying type I variable does not contain a definition for greet, and no extension method greet of type I variable could be found. I'm missing any assembly reference. So basically it tells me that since G3 is declared as a type I variable, so when it tries to invoke the greet method, it is going to only look up here and find out, hey, there's only one method, which is fly. There's no greet method here. So therefore, it won't even bother to check if G3 is actually a griffin that actually may be able to invoke the greet method.
So again, this is subtle. Don't worry, this is not going to be on the final exam. But just take a minute and see if you can get this in your head. So on the right-hand side here, they're all really griffins, right? Whoever wrote this line of code intended them all to be griffins. But what we've done by the way we instantiated the variables called G1, G2, G3, G4 is going to influence what you can do with that identifier, G1, G2, G3, G4. G1 can do anything an animal can do. By the way, animals can greet. Therefore, G1 can greet. Now, in this case, G1 will greet appropriately for a griffin because the greet class is overridden in griffin. G2 is a griffin and it's declared as a griffin. Well, it will greet. G3 really is a griffin, but we declared it as an iFlyable. And what can iFlyables do? All they can do is fly. Therefore, you cannot greet G3. So, subtle difference, right? And let's see, G4, anybody want to guess? Can G4 greet?
G4 is declared as iMammal, which
Probably not, because if you look at iMammal, all they can do by themselves is breed.
So say like you override a method, and then what if there's a class, kind of a child class of that class? When you said override, would it go back to the first class, like the grandparent class, or would it go back to the parent class?
How is it declared?
So I was thinking here if like
So let's take the animal dog husky example.
okay.
Okay, animal dog husky.
So let's say you had an animal method and it said like, hello, my my name is Animal, like that's its greet method. And then you used virtual there.
Right.
So then if you go to the dog, you would say like override, and then for the greet method it would be hello, my name is dog. And then if you went down to the husky, would you like say
Override again.
override? You'd override again.
Right again.
Okay, but there's no virtual in the dog.
Oh, actually, that's an interesting question. You may have to try this, Shuei.
I don't know if I can try it. I don't have 3 levels inheritance right now.
Right. But I don't think you have to once you got the virtual one at the top one, you can keep overriding, right? Like 2-string.
Right,
Right,
yeah.
we keep
yeah,
overriding
yeah.
2-string as
Yeah.
often as we want, right?
Yeah.
So I'm pretty sure. I
Yes.
think you just say override,
Sounds
and
good.
then you can have another greet method,
Right, yeah.
and then in that structure, no matter how you declared as animal or dog or husky, they would all get the appropriate greet method for their instantiation.
I was wondering if what the computer does, because you said it looks for the word virtual to say, oh, is there anything that was this, overridden? But then when it says the word override, it must check again if there's anything.
So again, it will always, and you mentioned inheritance has some inefficiencies, so this is why. Sometimes it's complex to find exactly the right method to use with this identifier.
All right, let's go back to our program. So now the third line say I can fly. Where does that come from? G3. What is G3? G3 is I flyable. Let's declare as Griffin. So how does Griffin fly? Griffin's fly method basically just print out I can fly. That's it. It is not greeting, so therefore it only print out I can fly. E1, which is declared as eagle. How does the eagle fly? When eagle flies, say, hey, I am blah blah the eagle and I can fly. And as you can tell, I am Alan the eagle and I can fly. And similarly, E2, which is declared as I fireable and then assigned as a new eagle object. So when E2 invoke fly method, it will check out this method and find out E2 is an instance of eagle. Therefore, it's going to invoke this method, which is I am Frank the eagle and I can fly. Now we have this child breeding thing. So we have make G4 breed. G4 is iMemo, so therefore it can invoke the breed method. And what does memo? But G4 is Griffin, and how does Griffin breed? It just returns junior something the Griffin. And because G4's name is David, so therefore you see name of G4's descendant is Junior David the Griffin. Alright, so any question for the rest of the code, by the way? Do you think you guys understand what it's doing or not?
Well, or maybe I'll just make a comment. Again, this is advanced stuff. This really is the heart of object-oriented programming. Let's say you wanted to do something sophisticated, like extend an existing game. There would be a series of these classes that the programmer had decided what to do and require you to do with a certain interface what the hierarchy of objects were. And when you wanted to change something, you would either need to extend that class hierarchy, add a new interface, or use what was already there. And so you would sit down first, say, okay, here's what I want to do. Can I do it with what's already there? If not, you would extend it. You would add another subclass via inheritance, or maybe make up a new interface to require things in the existing inheritance hierarchy that you wanted to declare to implement that interface. And, by the way, this should reinforce my basic thing I've been banging on for a while. This is why it's important to really pay attention to declarations, instantiation, and initialization. There really are 3 separate steps.
Okay, so because this part is really not required to for you guys to understand, so the point of this lecture is to show you that you can use this interface to make the Griffin look like it is inheriting from 3 classes at a time. But what actually is, it's just inherit from 1 class and implement the other 2 interfaces.
And so the way I think of interfaces versus inheritance, interfaces obligate you to write things in the class itself. Inheritance gives you a way to use things from a class somebody else wrote. And so that's why it gets around the quadruple sister aunt problem.
Yep. Okay.
And so we're probably going to need to wrap up so we have time to work on the lab for a good hour plus.
All right. So so basically that's almost the end of this lecture. So what's the benefit of using interfaces? Well, the first thing is with fake multiple inheritance, it reduces the code complexity that is introduced by using inheritance. Second thing is not required to you guys to understand. It's called decoupling between classes. So usually what software engineering doing is that we don't want 2 classes are bounded too close. Therefore, we add an interface between them so that they are only dependent on the interface instead of depending on classes directly. This concept will be more explained in the Comp 313 413 class, which is the intermediate object-oriented programming. And third thing is more abstraction. Of course, with an interface, you only need to care about the interface, its behavior. You don't need to worry about the implementation of the method because you know that if that class implements that interface, you can invoke those methods and expect it to do something for you. So therefore, it gives you more abstraction, and you don't need to worry about the complexity behind it.
And so again, in your custom project, I'd like to encourage you to think about interfaces and inheritance. And again, Yubing and Catherine and I will be your design consultants. Yubing's example of the fly interface is really a good one because again, it makes sense to have some animals can fly, but not all. But think about it, the way he introduced it as an interface. Then if you wanted to have airplanes that could fly, cars that could fly, what else could fly? Spaceships that can fly. You've already got an interface defined to do it. So it gives you this reduction in complexity by separating things out. The official word in computer science is the coupling and cohesion. You make your classes and interfaces loosely coupled instead of deciding some animals can fly and some airplanes can fly and some animals can eat, but we don't want airplanes to eat.
No.
So instead of figuring that all out, I said, okay, maybe I'll have an interface for eating, I'll have an interface for flying, and certain classes will implement.
Okay, so a wrap up for today's lecture. So we first covered about the basic object-oriented programming concepts. So objects are instances of classes, and classes are just the abstraction of certain of data. And instance variables are the states of an instance that you create, that you can access to it and figure out what the state of that object is. An instance method describes the behavior of its of a particular object of a class. And then we cover
things a little bit about inheritance. So inheritance, the aim of inheritance is just to increase the reusability of code, so that programmers don't have to write the same thing over and over again for it every time they have a new problem. C# only supports single inheritance, so don't even try to make a class in C# that inherit two classes, because it's impossible. Derived class implicitly gains all the method, so and you can only access the public unprotected method from the derived class. Interface, which is a little bit more advanced topic, is there to help reduce the complexity of code and reduce the dependency between classes, and it's there for you to mimic multiple inheritance. So if you want a class to have to do multiple things at a time, you better use interfaces instead of inheritance. Alright, that's for today's lecture. So here's some reference, the book that I looked up while I'm preparing for the slide and lecture, so you're welcome to look them up. Okay.
Thank you, Evan.